Hey everybody, happy Monday. Hope you had a great weekend. I'm going to jump right in today because we've got a new topic that's a little new, I guess is the word to say. It's not difficult. I wouldn't say it's difficult by any means, but it is new, and so it might be a little bit confusing at first. So today we're going to be talking about Punnett squares, and I'm going to do things a little bit differently today. So I've got a whiteboard. Hopefully this works out well. You're going to see me get awful close to the camera today. Sorry, you have to stare at my face a whole bunch. But let me write this out here. So a Punnett square, look at that. T square. Okay, so a Punnett square is basically a tool that we can use that'll make predicting what you're going to look like or what your genotype is going to be much easier. So Thursday and Friday, I was having you do things like write out genotypes, like, hey, if your parent has big B and little b, and then what are the possible genotypes if you have that parent, right? This makes that way easier. And then once you get the hang of it, it's actually kind of fun. I've always enjoyed Punnett squares. Ooh, I forgot my S. What a beautiful S that turned out to be. So I think you guys will like this, but let me kind of explain how this works, and let's see how good I am with this whiteboard. I don't feel super great, but we'll try it. All right, let's clear this guy up. So a Punnett square, if you want to look in the book to follow along with me here, it's not a bad idea. I'm looking at 340, 341, and then we'll go into 342, 343. I'm just going to use those examples, because they're real world examples and they're really easy. And it's a good way of explaining this. Let me go to skinny pencil here. Okay, so a Punnett square, what it's used to do is if I'm going to cross two parents, so we're going to start with two parents in each case. Okay. And then I want to know if I cross them together, if I breed those two parents, what are their offspring? What possibilities will their offspring have? Okay. So the first thing is you need to understand what traits the parents have. Remember, we get our traits, we get our DNA from our parents. It's not identical, it's a new combination from our parents, but we need to know what genes they have to begin with. So we're going to use 341 here. We're going to use the pea plant example, and this is actually what Gregor Mendel did. He was studying pea plants when he first kind of came up with this notion, and so we're gonna stick around with what he did. Now we've got two parents here. If you look at 341, and there's a key in the top left here of 341 that tells us what each of our alleles mean. So we've got a big R and we've got a little r. Okay. Now if you look, it says big R is round P, and then little r is wrinkled P. Oh dear. There we go. It's not quite as easy as writing on paper, but it'll do. Now, if you notice, and if you remember from last week, big R right here, that one is dominant. So if I have one big R as an offspring, if I get one big R, I am going to be round. Okay. All it takes is one dominant trait for that to show up in my physical characteristics in my phenotype. Okay. So if I'm an offspring and I get a big R, I'm going to be round. Now, if you remember from last week, in order to be wrinkled, I would have to have two small r's. Okay. You cannot have a recessive trait show up in your phenotype unless you've got two of them, unless you get one from each parent. Okay. This is really, really important. And if all that I'm saying right now is complete nonsense, you got to go back to last week, look at those videos because it fits together. Okay. All right. So a Punnett square, it looks like a window. It's always going to start off like this, and then you're going to draw a little cross through it, and you got your window. Okay. Now get used to this shape. You're going to be seeing a ton of these. The first thing you want to do is figure out what characteristics do your parents have. Okay. So one parent here is big R, little r. So I'm going to call them P1 equals big R, little r. And then P2, they are big R, little r as well. And again, if you have no idea where I'm getting this, I'm at 341 right now in your textbook. Okay. So parent one always goes, it doesn't matter, but they always go up on the top here. You're going to take these two alleles from parent one. You're going to put them up at the top here and here. Okay. Parent one will go up there. Again, it doesn't really matter. If you put parent two up there, whoop-de-doo, it'll still work out. Okay. Parent two then is always going to go on the side, and we're going to take the big R and the little r. Okay. So you see, now we've got it set up. So parent one is always going to be working like that and like that. And let me undo that. And then parent two is going to be working in this direction. Okay. Oh, let me get rid of that as well. Okay. So here's the fun part. We're saying that parent one is breeding with parent two. They're going to have some offspring. Okay. We don't know how many. This is important. A Punnett square is not telling you how many offspring you're going to have. It's telling you what are the possible outcomes for your offspring in terms of traits. Okay. So this is really, really easy now. All we do is we take this big R and we go down. Okay. We put it down here. We put it down there. We take this little r and we put it down as well. Right there and right there. Okay. That does it for parent one. So parent one has contributed now their traits to these new offspring. Again, we don't know how many there are, but we'll talk about a little bit more why it's a 4-quadrant window shape in a second. Okay, so that's parent one's contribution. Now parent two is going to work to the right. So this big R is going to go here, and it's going to go here. And then this little r is going to go there, and it's going to go there. Now you notice, maybe you did, maybe you didn't, that I always put the big letter on the left of the two here. Okay. Now there's no big one in the bottom right quadrant. I always put, you want your dominant trait to start. In other words, you don't want to write, like, look at quadrant 3 right here. You don't want to write it like this. Okay. It's just uglier that way. No disrespect to this quadrant, but you always want, if you've got a big letter and a small letter, you always want the big letter to be on the left. It looks neater that way. Let me get rid of all that. Okay, so you might be thinking, what the heck are you doing? What is this thing? I don't understand what the point is. Okay, this is actually it's a probability calculator. Okay, probability. Oof, this is looking rough. My screen is like bouncing. I think I forgot an I in there, but who has to know? That's the worst looking probability I've ever seen. I apologize. Okay, so probability is it's math. Okay, we know that math and science are very closely related. This is telling me what are the odds that my offspring are going to get a certain number of traits. Okay, or a certain combination of traits, I should say. So if I've got parent one who's big R, little r, I got parent two who's big R, little r. What are the odds that their offspring is going to be big R, big R? What are the odds that their offspring is going to be big R, little r? And then what are the odds that it's going to be little r, little r? Okay. So this is a really useful math tool to tell us what are the odds that you're going to get a round or a wrinkled pea plant. Okay. So what we like to do now is, now that we've got all of our quadrants filled in, is we like to go genotype. I've redeemed myself after that probability. So my genotype options, look at how many different combinations are there inside that Punnett square. I've got big R, big R. I can get big R, little r, or I could get down here, little r, little r. Okay. So if these two parents were to breed, their offspring could potentially be any of these three things. Okay. Basically, these are your options for offspring genotypes. What would they possibly be? Okay. Now, my phenotypes, I'm only going to have 2 different phenotypes here. And sorry, I don't want to draw it on my face, so I'm going to put it down here. So phenotype wise, I can only get 2 different results. Okay. I can get round, or I can get wrinkled. Now let's talk about that for a second. These three quadrants, this one, and this one, all represent an offspring that would be round, okay? This fourth one right here, this represents an offspring that would be wrinkled. Remember, in order to have the recessive trait, the small r, in order to have that, you have to have two small r's, okay? So if you were to breed these parents together, they could potentially make a round seed, or I'm sorry, a round pea, or they could make a wrinkled pea. It's all a game of probability now, okay? Let me wipe some of this stuff out over here. I wish I could make my eraser bigger, but bear with me. Okay, so now let's talk about probability. What are the odds? So you can use a Punnett square to determine what are the odds that I'll get a wrinkled seed, or I keep saying seed, sorry, a wrinkled pea plant or a round pea plant, okay? So look at this. We've got 1, 2, 3 boxes of our 4 that have the dominant trait in them, okay? 3 out of 4 have the dominant trait, and we know that if you have one dominant trait, then you are going to have whatever that trait is. You're going to be round in this case, okay? So for round, I'm just going to put R here. There is a 3 out of 4 chance that an offspring would be round, or we could write it as 75%, okay? And then that leaves the last one here. There is a, let me do W, 1 in 4 chance, or 25% chance that you are going to have an offspring that is wrinkled, okay? Now here's the big thing. Students will often get this mixed up. They think that a Punnett square, this entire diagram, they think that it's telling me that I'm having 4 offspring, okay? This is not to determine how many offspring you're having. The entire purpose of a Punnett square is so that you can determine the odds that you'll get one trait versus another in your phenotype, okay? I hope that makes sense. So I'm not having 4 pea plant babies here, okay? That's not what this Punnett square is saying. What this Punnett square is saying is if I take a big R, little r, and I breed it with a big R, little r, I got a 75% chance that I'm going to get a round, and I've got a 25% chance that I'm going to get a wrinkled offspring, okay? I know that's a lot. We're going to do another example here. And then, like I said, once you get the hang of this, it's kind of fun because you can figure out if I breed certain things together, what are the odds they're going to look one way or the other. So let me clear this board. And then I'm going to turn the page here, and we're going to do, I believe it's guinea pigs. I don't like the guinea pig example. Actually, let's do the one on 342. The one on 343 is basically what we just did. So there's no real reason to do it again. Okay, so we're looking at guinea pigs. I'm reading 342 where it says do the math at the bottom. In guinea pigs, the dominant big B allele is responsible for black fur. Now, here's the first thing I want to do is figure out what are my alleles, okay? What do they represent? So big B is black fur, okay? And let's see. While the recessive small b allele is responsible for brown fur. So we've got little b is brown. Okay. So now we know kind of what we're dealing with. We got guinea pigs, we got fur colors. It says use the Punnett square to find the probability of this cross resulting in offspring with brown fur. So the question's not just saying do a Punnett square. It's saying figure out the probability that I'm going to get an offspring with brown fur, okay? So that's our main objective in the end. So I'm going to draw my window. And then we got to look at our parents. So remember parent 1, sorry, I'm bothered by that, but I knew I was going to make it worse. So parent 1 is big B, little b. There we go. And then parent 2 is little b, little b. Now, let me ask you this before I go on. I want you to answer this just in your head, Dora the Explorer style. Just yell at the screen. Parent 1 up here, what color fur do they have? And then parent 2 down here, what color fur did they have? Okay, I want you to answer that right now, and then I'll tell you the answer. Did you answer it? Perfect. Okay, so parent 1 has one big B, which tells us that parent 1 is going to have black fur. Okay. Parent 2 down here has two small B's. That tells us that parent 2 is going to have brown fur. Okay. In order to have the recessive, in order to have the little b trait, you got to have two of them. That's one of the big keys here. Okay. So let's do our cross now. Remember, parent 1 up top, those are just going to drop down. So I'm going to take my big B and drop it down into those two boxes. And then I'm going to take my little b and I'm going to drop it down into those two boxes. Okay. Now, my parent 2 is going to go from left to right. So this little b is going to pop into there and into there. And then this one down here is going to go there and there. Let me double check, make sure I do that. I always like to see, okay, did I drop them down properly and make sure they're in the right boxes? So yes, 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 and yes. Perfect. Now, the original question was, what's the probability that we're going to get an offspring with brown fur? Big key here. I'm not looking at 4 offspring in this Punnett square. This is not telling me you just had 4 guinea pig babies. If you did, that's not good. You should get yourself checked out. Hopefully you're not having guinea pig babies. So I got to check and see my genotypes first. So my possible genotypes. I could have a big B, little b offspring. Actually, there's 2 of those in there. Or I could have a little b, okay? Which means my phenotypes, I don't know why I wrote an R. Phenotypes. I could get a black or brown. Okay. Now, still haven't answered it, but I always like to do this. I always like to tell, in my brain, organize everything. What are my genotype possibilities? What are my phenotype possibilities? Even if it doesn't ask me, I still like to do that just so I can keep everything straight in my mind. I don't get confused. Now, let's go back into the Punnett square. I've got 2 that I know are going to have black fur because this is when you shout the answer out and I can hear you. Because they have one big B in them, okay? At least one big B equals whatever that trait is, black fur, okay? Then I've got 2 here that do not have a big B. So I can guarantee those guys are going to be brown. They do not have the dominant trait, the big B, so they're going to be whatever the recessive trait is, which is brown, okay? So I've got 2 out of 4 are going to be black. And then I've got, let's see. Sorry. And then I've got the other 2 out of 4. I don't know what that was. That are going to be brown. Now, it depends on the question. Some questions will say put it in a percent. Some questions will say just give me the probability. You can really do it however you want, and as long as the question doesn't say. So I could leave this as 2 out of 4 chance that I'm going to get brown. I always like to use percent, so I'm going to just say it's a 50% chance, okay? Does that make sense, hopefully? So we've done a big B, little b parent. Actually, both parents in the first example were big B, little b, and then now we've got a big B, little b, and then 2 little b's. Let me clear this, and then that was not scrolling. Here we go. And then we'll do one more. All right. I'm going to make this one up. I'm not going to go off of the book. I'm going to draw my Punnett square over here. All right. Let's talk about what's a good trait. We'll do eyes. I always like to go back to eye color. So in eyes, in humans, big B is dominant, and that's your brown eyes. Little b is recessive, and that's your blue eyes. Okay, so let's say parent 1, let's say they have brown eyes. Okay, so parent 1, brown. Parent 2, say they have brown as well. Okay, now this is really important. Just because your parent has brown eyes, okay, just because they have the dominant trait, that does not necessarily mean that they've got 2 big B's, okay? They do not necessarily, okay? So in order to have brown eyes, you could be big B, or you could be big B, little b, okay? And there's a reason why I'm talking about this. I'll explain in a second. Let's say that both parents here are big B, big B. Okay. Now, to do our Punnett square, remember, top ones go down, and then the side ones go to the right. The left side goes across. Okay. So if I asked you, what are the odds that two brown-eyed parents that are both big B could have a blue-eyed child, okay, a blue-eyed offspring, you could immediately look at this Punnett square and see every single one of these boxes has a dominant trait in them, at least one dominant. In fact, they both have, or all of them rather, have two dominant traits. So you can tell right away it is physically impossible, except for some kind of mutation or strange thing happening, for two big B parents to have a recessive offspring. Okay. It is a 0 out of 4 chance that these two parents could have a blue-eyed offspring. Okay. Now, this is where some people get confused and they say, well, wait a second, both of my parents have brown eyes, but I have blue eyes. So am I adopted? Okay. Well, great question. I can't answer that 100%, but I can give you this to kind of help you. Same situation, Punnett square. If I have two brown-eyed parents that are not big B, but instead big B, little b, watch what happens. Big B goes down, big B goes down, little b, big B goes over, and then little b goes over. Okay. So I can still have two brown-eyed parents, parent one, parent two, both have the dominant trait and therefore have brown eyes. But look at this. You got a 1 in 4 shot for blue eyes in your offspring. Okay. So you didn't necessarily get adopted because you've got blue eyes and your parents have brown. Okay. So you can see, remember we talked about how the dominant trait kind of hides the recessive trait. The recessive trait's still there, but you don't see it, and therefore you don't think it's there. This is how you can have blue eyes with both of your parents having brown eyes. Okay. So in my case, I've got blue eyes. My dad has blue eyes, so he would be little b. Actually, let's do this one because it's pretty interesting. Sorry, I'm going to get selfish and do my own Punnett square here. So my mom has brown. My dad has blue. So we know my dad's little b. He has to have two little b's in order to be blue-eyed as a phenotype. Now, if my mom was big B, that's a very big B, sorry. Look at what happens. The big B's drop down, and then every box has a big B in it. So it would be impossible for me to have blue eyes if my mom was big B. But luckily, we can tell that she's big B, little b, because now watch what happens. All of a sudden, we've got a 2 out of 4 chance that you're going to have little b, or a 50% chance of blue eyes. Okay. So you can see now there's a lot of complexity that goes on, and all of these examples are very simplified. Especially for eye color. Eye color is controlled by, I want to say it's like 12 or 14 different genes. So you don't necessarily just have two alleles that make up your eye color. It's a bunch of different ones. Don't quote me on that number, but I know it's more than just two. So everything here is pretty simplified, but you get to see the complexity behind when two parents breed. Their offspring could have a number of different things that they never had themselves. Okay. So this takes us all the way back. Let me clear this board to when we talked about asexual versus sexual reproduction. So remember, asexual reproduction, one individual by themselves becomes two new individuals. Okay. And remember, those offspring are what? They're genetically identical to the original parent. So let me take note of that. So in asexual, you get genetically identical. And then in sexual reproduction, remember, you've got two parents that are breeding, and you are going to get differences, genetic differences. Let me write in the word genetic. Okay. And you remember what we talked about, why this is so important. Asexual has so many advantages. It's fast. You don't need to look for a partner. You don't have to be female to reproduce. The males can do it as well. So asexual has all these different great things. But now we talked about in more detail the genetic differences. You can have traits pop up in sexual reproduction that weren't there before. Okay. And that's so important when the world starts to change. And we know the world's changed. Remember back in our last unit, we talked about, the world was covered in ice for most of the world was covered in ice for an extended period of time. We know the world's getting warmer right now. And so as these environments change, the ability for genes to appear and disappear and still be kind of behind the scenes, even though your parent doesn't show it, it can still be passed on to you. That's so important when it comes to surviving in a changing environment. Sorry, I keep looking out at the window because I'm talking about environments changing. It looks like it's about to rain. So when we talk about this, the Punnett squares and the probability, think back to sexual reproduction. That's the genetic variation that we're talking about. Your offspring can have things that as a parent you never had. Okay. And that's so valuable when it comes to surviving in changing environments. And we'll talk about that more in detail later on. We're going to talk about how things have changed over time in terms of living creatures. But for now, I'm going to leave you here. I'm going to have a little bit of a worksheet per se for you to do that will hopefully make sense of this Punnett square. At least it'll give you some practice. But stay tuned for that. And then tomorrow we're going to kind of go a little bit more in detail with this. I just wanted to give you the base level of Punnett squares. Hopefully this makes sense. Shoot me an email if it doesn't. I've had a couple people say, hey, I'm completely lost. Can you help me out? And we can set up a time to do a video chat or whatever. But send me an email if you're stuck or confused. I'll post that worksheet, I think, within the next few minutes here of when you see this. I think I'll do it probably a little bit differently than we've done. So stay tuned. That'll be coming your way. I want you to practice your Punnett squares. Remember, parent one, if we have let me do a quick little box here. Parent one is going to go up here, and then parent two is going to go here. You go down and down, and then you go across that way. Okay. So it's that simple. Good luck. Again, shoot me an email if you get stuck on anything. I'll see you guys tomorrow. And we'll do some more Punnett squares. See you then.